Biochemistry and Cell Organisation Taskbook, question 2, model, answer and commentary. The diagram shows the components of one type of lipid molecule. Name the components. Hopefully you've learnt these. Component A is glycerol. Component B, we don't know which type of fatty acid, so we can only just say fatty acid here. There we go. Draw a ring around the atoms that would be removed if a bond were formed between these. So if a bond were formed here, what would get removed? Well, water would get removed in a condensation reaction, so we need just to draw a ring around water, H2O. We're not worried about which O we choose at the moment. And the type of chemical reaction, condensation. And that's any reaction building things in biochemistry, generally condensation reactions. Complete the diagram to show the structural formula of a compound where 3 molecules of B, these, come bound to 1 molecule of A. So to do this, we need to just look at this answer here and just imagine if that water disappeared, we'd have an O and joined onto a C. So we'd have O there, then joined onto the C, and then the rest of it's just exactly the same. So double bond O, and then our little wiggly line there. And we're going to do the same down here and at the bottom. So we have got 3 molecules. So we're just going to do the same there. C, I'll just squeeze that in, and the wiggly tail is going to be the same. And there's going to be 1 mark for putting the oxygen in the right place, and the other mark is for carbon with a double bond oxygen attached to it. Name the type of lipid. Well, monoglyceride, diglyceride, triglyceride. There's 3 fatty acids attached. So this is going to be our triglyceride. State 1 function, so 1 only, of which these compounds perform in animal cells. So I can't say anything to do with plants here, although we know lots of things. So let's go for the most popular one. So it's the storage of energy. So storage of energy, things like storing fats in seeds and things like that. We could also say that would be plants, storing fats around your body for energy storage, and same in animals. We could also say something like producing respiratory water, but that's the most obvious one. Now we can talk about fats in plants. Cooking food in olive oil is believed to be healthier than using animal fat. Is believed here, and the science isn't too sure about this. However, we're going to go with the Markscheme. What type of disease is believed to be affected? That's coronary heart disease. So coronary heart disease. We could also say things like atherosclerosis possibly. How does component B, so that's this component here, of olive oil differ from component B in animal fat? Well, plant fatty acids are more unsaturated, either monounsaturated or polyunsaturated, so they have double bonds. So they are unsaturated, so have carbon to carbon double bonds in this tail here. So instead of carbons all having as many hydrogens as being saturated with hydrogen, they're going to have carbon-to-carbon double bonds where you don't get so much hydrogen. Give one other difference between fats and oils. Most obvious one possibly are fats are solid when we encounter them at room temperature. Whereas oils are generally a liquid. Think of olive oil. Oils are liquid. And there's 11 marks.